these four, Jupiter's largest moons, known since 1847 as Callisto, Ganymede, Europa, and Io, are each about the size of Earth's moon, and they are easy targets for amateurs. In fact, when Jupiter and Earth are close together, as they were for Galileo in 1610, you could actually see them with just your naked eye, if not for Jupiter's dazzling glare. Each of Galileo's four moons is a sizable planet in its own right, and each has a unique personality.
So we think Europa is mostly rocky, but the surface, and maybe the upper 100 kilometers even, is composed of mainly water, and at the surface that water is solid ice.
It's incredibly smooth compared to other satellites around Jupiter and elsewhere in the solar system. Very few impact craters are seen on its surface, so its surface looks relatively new and fresh. And when you look at the surface in detail, what you see is this vast network of cracks that have reminded people of what ocean ice looks like, say, around the North Pole.
And when the geologists first looked at the pictures that came back, they said to themselves, holy mackerel, that looks like what we see in Antarctica when pieces of ice break off of a glacier and they twist.
There is as much liquid water on Europa, roughly speaking, as there is in the oceans of our own planet Earth. Because Europa is smaller than Earth, that ocean's very deep, maybe 50, 70 miles deep. But the ice on top of it is probably pretty thin, maybe only 5 or 10 miles thick.
The reason for water below the ice surface is tidal flexing. It's Europa's situation, being next to Jupiter, being bounced back and forth by tides that causes heat to dissipate. Without that tidal heat, the ocean would probably be frozen all the way to the bottom.
We have to go back to Europa to determine whether the crust is thin enough that the ocean can actually be sampled, the crust could be penetrated.
It would probably be done by simply having a spacecraft that was warm, and it would land on the ice and melt its way down through the ice all the way to the ocean.
We stand now amidst the ice floes of Europa, in awe of giant Jupiter, and dreaming about what may be living in that immense ocean far beneath our feet. In other latitudes on Europa, long lanes of ice have cracked and frozen time and time again in response to Jupiter's titanic tidal pull. Just as earthly life's evolution was encouraged by shifting seas under the pull of our moon, so may Europa's constant dance of renewal to Jupiter's bellowing call stir the mix of biology deep beneath the ice.